Now let's go ahead and try to add a new follower. So at the moment we have one leader, we have one follower. Now we want to add a new follower. How would we go about doing this? So theoretically, we take snapshot of the leaders database at some point in time. And usually we do it without taking a lock on the entire database so that writes can happen. And most databases have this feature which is required for backup. And in some cases, third-party tools are needed, like Backup X for MySQL. So we have a snapshot for the leader at some point in time. Now let's go ahead and add another follower. So the new follower, we have the new follower. The follower is going to go ahead and import the data from the snapshot. Now the replicas also maintain a replication log. Whenever a write happens, the information is kept in the replication logs. So while follower 2 is importing the snapshot, the leader is maintaining the replication log. So it makes sure it has the information about the writes it's receiving. In the meantime, follower 2 has finished importing the snapshot from leader 1. It is going to go ahead and reach out to leader 1. It's going to say, hey, I have imported the snapshot. The last write in the snapshot corresponds to this point in time in the replication log. Please provide me the other writes that you have received after that. The reader is going to send out the rest of the replication writes to the follower 2. Follower 2 is going to import the missing replication log that it missed while it was importing the snapshot, and follower 2 is now caught up. The snapshot is associated with an exact position in the leader's replication log. The position has different names. PostgreSQL calls it the log sequence number, while MySQL calls it the bin log coordinates. So this is it. In a single leader replication, this is how we can add a new follower. So we could have various types of replication logs. We could have a statement-based replication, which is the simplest form of replication logs. So each time a leader processes a write, it also writes the statement in the log. The write statement could be insert, update, delete. So the leader just goes ahead and write the statement as it is in the replication log. It also write other metadata, for example, timestamp of the statement or position of the statement in the replication log. So that way the follower can go ahead, ask the leader for the replication log that it might have missed during it was down, or maybe when it is added newly. So if there was an insert query that the leader executed, so for example, insert into some table, the follower is going to find that insert query and execute the insert query statement on its database. The problem with statement-based replication is that functions. So for example, if I had a function which returns different values when it is executed. So for example, we have a function called rand, which is going to return different values different times. So if the leader executes it in the leader, it might get maybe a value which is different from the value that the follower might get when it executes the function. So in that case, what the leader could do is go ahead and replace the value, replace the function with the value that it got in the replication log. That way the follower would end up getting the same value. So statement-based replication could have other problems as well. Now the statement-based replication was used in MySQL before version 5.1. Now it has switched to row-based replication. So another type of replication is write-ahead log. Now we have write-ahead log. Once the leader accepts any writes, before writing it in the local storage, it's going to go ahead and write the modification in write-ahead log. So each modification is in the same order, in the same sequence, in that val is a append only sequence of bytes. So we could think of val as a file that we are appending to, and appending anything to the file is going to be much faster than persisting it on a database. Once it makes the changes to val, it is going to send out the same changes to all the followers. This method of replication is used in PostgreSQL and Oracle. Apart from that, val has some other advantages. So for example, maybe the leader has accepted a write. The write requires us to perform 3 actions. So the leader is first going to write the changes in val. So maybe the changes are ABC, and then the leader is going to apply the changes one by one. So it has applied change A, and then it started applying change B. Halfway through, maybe it crashed. Next time the leader is brought back up, it could compare the changes it has already made and the changes that it needed to make, and that way we could bring back the changes that might have been missed. Next, we could have a trigger based replication. So if we create a trigger, the trigger is going to execute automatically when a data change occurs. We could create a trigger in that if something happens in database, if a new row is inserted, something is updated or deleted, the trigger is going to be executed automatically, and maybe that trigger can go ahead and write the changes to another table in the database. And then we could have an external process that is going to read that table and forward the changes to the other follower nodes.